everyone, and welcome to Solar Alberta's 2022 seminar series. Today's webinar is called Solar Ready Design, How to Build a Greener Future. My name is Mackenzie Velders, and I'm the Public Outreach Lead at Solar Alberta. I would like to take a minute to acknowledge that I'm presenting to you today from Fort McMurray, Alberta, on Treaty 8 territory and the homelands of the Métis. This land is the traditional gathering place of the Cree and Dene. We were delighted to have so many people register for this event. Please note that we will be recording this webinar for future distribution. Today, we will be hearing from two Solar Alberta speakers about how to ensure homes and businesses are built or renovated in a solar-ready way, and we'll share some great examples of solar installer and green builder partnerships. Following the presentations, there will be a Q&A period in which you can all participate. The formal Q&A will run until about 1/4 the hour, and then we will be inviting you to join us for an additional 15 minutes in a more relaxed Zoom meeting Q&A at the end. The link for the extended Q&A will be posted in the chat at the end of the formal Q&A, and I will draw your attention to it at that time. So please make sure to click on the link before leaving the webinar. The entire session will wrap up in an hour and a half. In an effort to increase accessibility to the content we are offering, we have enabled closed captioning for this presentation. You can turn the captioning on in the toolbar at the bottom of your Zoom screen. During our formal Q&A period, we will be using Zoom Q&A for questions rather than the chat box, so please enter your questions in the Q&A section. Also, please click on the little thumbs up symbols to upvote questions you like. Before we move forward, we are going to do a quick poll to get a sense of who we have joining us today. Megan will be launching this. Please take a minute to answer the question popping up on your screen now. And while some are still doing the poll, I encourage you to also take a minute and pop your name, land acknowledgement, and any contact info you're comfortable sharing in the chat now and throughout the event so that others can look you up on LinkedIn or email you and some relationships can begin to be formed. We'll just give that a few more seconds, that poll. Wonderful. Thank you very much for participating. It's always helpful to know a little bit about the audience before we dive in. So it looks like we have about 28% of attendees who are professionals in the solar industry. About 15% are solar industry students. A majority are solar curious, and then we also have a few green builders in the audience today. So I'll get Megan to end that poll now. And now I will share a little about Solar Alberta. Solar Alberta is now in its 31st year of operation. We are a not-for-profit society that is dedicated to accelerating Alberta's transition to a just and sustainable energy future. We do so by advocating, educating, and serving as an industry and community hub for solar energy. Our membership is made up of over 320 individuals and businesses. We provide a number of services, including managing the solar directory through our website. In this way, we act as a bridge for installers and suppliers and other solar-related businesses to connect with their customers and clients. You can see a screenshot of the directory here on this slide. This spring, we completed a number of online courses for solar industry professionals or those transitioning into the sector. If you weren't able to attend the live classes this spring, you can still purchase pre-recorded courses and workshops on our website. We will have another round of classes starting live online in October. And if you are not already, I would like to encourage you to join Solar Alberta as a member. We are constantly evolving member service offerings, some of which you can see listed on the screen. Individual membership is $35 and can be purchased at solaralberta.ca. Our next Thursday lunch hour seminar will be on August 25th. You'll be hearing from 3 different speakers about solar energy, energy storage, and electric vehicles. Stay tuned to our social media and newsletter to learn more about when our events will be. And you can also find archived videos of our previous webinars on our YouTube channel. I would like to take this opportunity now to give a big shout out to Habitat Studio for sponsoring today's seminar. We are happy to have them as a sponsor. We are always interested in developing more partnerships for our events. If you or your company want to work with us to educate the public about solar or related technologies or opportunities, please don't hesitate to reach out. Now I will pass the mic over to Rick Young, who will provide an introduction to Habitat Studios and introduce today's speakers.
Hello, thank you, Mackenzie. As Mackenzie mentioned, I'm Rick Young. I'm a managing partner at Habitat Studio. We've been designing and building custom homes for the last 30 years. Our focus has always been around energy efficient design, construction. And in 2008, we built the first net zero home in Edmonton. 3 years ago, we decided to expand what we were able to offer our clients and hired John Joel from the Native Alternative Energy Program to run a PV division of Habitat Studio. So when we were given the opportunity to sponsor this seminar, it seemed like a perfect fit. With an in-house architectural design team and a PV design team in the same space, we're able to put together true solar-ready designs for our clients and not just offer that conduit from a mechanical room to a roof that may not work efficiently for a PV install. That coordination between architectural design and PV design in order to future-proof your building is the focus of this seminar. So from here, I'll hand things over to our presenters, Heather Mackenzie and Nick Kwan. Heather Mackenzie is the Executive Director of Solar Alberta, where she and her team are working hard to accelerate Alberta's transition to just and sustainable energy future. She's a seasoned leader, a community organizer, and green business advocate. Prior to becoming the Executive Director at Solar Alberta, she worked as a government relations professional, ran her own business, and served as an elected trustee in the Edmonton Public School Board. She's in the midst of completing a master's in public administration, has a master's in international development, and has undergraduate degrees in both sociology and history. She believes that investing in solar is a very concrete way that everyday Albertans can take meaningful action on climate change. Nick is an electrical engineer who's currently working with the solar industry as a technical consultant. He has over 4 years of experience in the Alberta solar industry, ranging from 10 kilowatt residential projects for homeowners to 100 kilowatt commercial projects for municipalities to 100 megawatt plus utility scale projects for Canada's largest developers. He has an interest in educating the general public about solar PV and is excited to be able to help contribute to shaping Alberta's current and future energy mix. So that said, I will hand the mic over to Heather and Nick.
Well, thank you very much, Rick, and thank you, Mackenzie. I'm just gonna adjust my screen here so I can see all my notes as we take it away. Great to see so many people in attendance today, and a nice mix there as well. So as many of you are likely aware, there is a very high demand these days for solar PV arrays in Alberta. And as you can see from this map, the Alberta actually has an incredible solar power generating potential. We are second only to Saskatchewan in the Canadian context. There are already over 8,300 arrays on homes and businesses in Alberta. And with the addition of numerous solar farms on the grid over the past few years and in the near future, the Canada Energy Regulator forecast in their 2021 Canada's Renewable Power Report that by 2023, 26% of Alberta's electricity capacity will come from renewable sources. That's up from 16% in 2017. So we have incredible growth in solar energy and of course wind production as well in Alberta. This incredible growth for solar is largely due to the price of solar PV dropping significantly since 2010. It's also related to our solar generating potential that you can see on this map. And of course in Alberta, solar farm developers are able to establish power purchase agreements, which is unique to our province as well. There are a number of solar incentive programs that are helping to propel the growth of solar. I think many of you have heard of the recent federal grant and loan programs that are intended to support energy efficiency as well as renewable power production. And there are, of course, local initiatives as well in many of the municipalities around our province. In addition to increased general demand for solar, there is specifically increased demand for both homes and commercial buildings to be solar ready. So new homeowners and business owners are keen to avoid any additional costs associated with retrofitting for solar at a later date. Not only are consumers demanding solar ready builds, but various municipal and provincial government officials have been calling us a lot over the past year or two to ask what solar ready builds are and how they can help promote those. So there is an appetite to increase regulation and incentives in this area, as well as for energy efficiency in general. As you all likely know, buildings are a major contributor to climate change. And so municipalities and others are working hard to figure out how to tackle the building challenge. With municipalities and other folks setting various goals related to emissions neutral new builds, it is a very good time to get ahead of this notion and learn more about solar ready buildings. So welcome to our presentation today. And I'll turn that mic over to you, Nick.
Thanks, Heather. So to start, it'd be good to define what we mean by solar ready builds. So with solar ready builds, essentially we're talking about preparing a building for the potential addition of solar in the future. So for the purposes of this presentation, we're going to focus on solar photovoltaic ready homes and businesses, as opposed to solar thermal. So solar photovoltaic, or solar PV, is kind of the technology that's taking off in Alberta right now. And of course, it's all about the sun's light as opposed to its heat. So for context, it's important to start by pointing out that a roof-mounted solar PV system will tend to be a lot more cost-effective than a ground mount system or any systems requiring additional mounting. So even if the angle of the home is not ideal, a bigger roof-mounted array will almost always be more cost-effective than a ground-mounted array. So therefore, we'll be talking mostly about roof-mounted solar PV today. For additional context, it's also important to understand that Alberta home and business owners under the microgeneration regulation are only allowed to generate as much energy as they consume in a year. So what that means is that if your home consumes 10 megawatt hours per year, that means your solar PV system can only be sized to generate 10 megawatt hours per year. So obviously, the higher the building's consumption, the larger the system might be by the microgeneration regulation. So now that we've kind of covered that, we're going to go into what key considerations we have for considering a solar ready build.
Great. Well, here we are. So one important procedural consideration for successful solar ready builds is making sure that all parties from start to finish of the project are aware of the solar ready requirements. Roof drains and vents may be shown on design plans and drawings, but if the other tradespeople on site ignore this equipment placement when construction happens, then it defeats the purpose of planning in the first place. So the key element in the successful solar ready builds is coordination between all parties. This means coordination between the architect, engineers, solar installers, and other trades throughout. Best practices involved in the management of solar ready builds include hiring architects and engineers experienced with solar design, involving a solar installer early on, coordinating between all design disciplines to determine things like rooftop unit locations, exhaust fan locations, roof access, and walkways, ensuring all trades are aware of solar ready requirements and place roof obstructions per the plan. Having the installation manager regularly check that all trades are following the solar ready plan can go a long way to achieving your goals. For those of you who have attended our passive house design workshop in the past, and you can find that at our website, solaralberta.ca, you'll have heard a very similar principle of the importance of getting everyone on the same page.
So now that we've talked about some of the very important kind of process related things that you want to make sure to ensure a successful solar ready home, we'll move a bit into technical considerations now. So as mentioned on the last slide, coordination is a very important thing. As well, obviously this is going to depend on the size of the solar PV installation. If we're talking about a 10 kilowatt rooftop system versus, a 1 megawatts commercial rooftop system, it'll obviously involve a few different trades and really differ in sort of the complexity that those systems will have. However, the general guiding principles will stay the same between the different sizes of projects. Those 4 guiding principles, which we'll go more into detail on the next slide, are kind of architectural and siting, structural considerations, mechanical considerations, and electrical considerations.
Great. So now let's get into the nitty-gritty, the detail of these considerations a little more. All right. First, we have our architectural and siting considerations. Ideally, we have a south-facing pitched roof with a slope higher than 312 for good solar radiance and some degree of snow shedding. The roof should also be relatively simple in shape so that roof area can be maximized for solar on the south-facing roof. Roof obstructions, such as plumbing vents or exhaust fans, should be placed on the north-facing roof or as close to the ridge as possible to maximize the space for modules. For commercial flat roofs, a torch on membrane type roof is preferable. TPO roofs may be slippery in the winter, and tar and gravel roofs pose structural and installation challenges for solar PV. Buildings, trees, and other tall objects to the south of the roof should be considered as they may significantly shade portions of the roof. If there is shading, then there are some solar PV products that are better adapted to shade, which should be considered. We should note here that these are ideal conditions for solar PV in many cases, such as the home I'm in. Other design or cost considerations might make these elements unfeasible to implement, and that's okay. Solar designers and installers can accommodate a wide range of conditions. However, these considerations should be made whenever possible in order to ensure the most solar-ready installation possible.
So secondly, we've got our structural considerations. Obviously, this is pretty important because if your roof can't accommodate the additional loads from solar, then the system will be either costly or downright impossible to install, as structural reinforcement is needed, which is a pretty hard thing to do in most cases. So typically, we recommend about 3 PSF, or pounds per square feet, in order to accommodate flush mount solar PV system. Which means basically your solar is going directly on kind of a pitched roof. So you can kind of see an example of that rather on the wall on the top picture there. But if you can think about that wall tilting over, that's kind of an example of a flush mount system. Now the requirements for a baluster system, where basically the array is held down by concrete blocks, kind of like how you see in the bottom picture. They'll obviously take a bit more loading because of the concrete blocks. So that'll be around 5 to 8 pounds per square feet for a system like that. So that's something we typically see more on commercial systems as opposed to residential systems. So obviously thinking about the structural considerations is important for residential roofs, but one thing to think about as well, especially as electrical vehicles are adopted more nowadays, is thinking about whether your garage can support the additional loads from solar as well. Sometimes what ends up being kind of a limiting factor for how much solar you can install on your house is basically your main house roof space. But if you're able to accommodate those loads on your garage as well, then that is great. So that's something to think about as well in the future is, hey, can I put solar on my garage as well? So finally, a solar designer, installer, or racking company should be contacted to give you a preliminary estimate for the solar PV loading on the roof and whether or not your roof is able to take the additional solar loads in the first place.
Yeah, thanks, Nick. And that last piece around garages is definitely going to be important because Solar Alberta has been having conversations lately with the government of Alberta about our hope for the removal of the consumption cap on micro generators. And I know that If we're successful in having that cap removed, then of course we definitely want all those garages to be additional solar homes for solar. So even if there's nobody living in them. So thanks for mentioning that. Thirdly, of course, we have our mechanical considerations, which are a bit more relevant for commercial flat roofs, where there are large mechanical units or gas lines located on the roof. This is similar to the architectural considerations. Essentially, ensure that any roof obstructions, including gas lines for commercial roofs, are grouped to the north side of the roof as much as possible in order to facilitate the maximum area for solar PV.
And finally, we've got our electrical considerations, which there are a few. So first, we want to make sure there's adequate wall space in the electrical or mechanical room for the main inverter. So this would be roughly 2 feet by 3 feet tall for a typical residential installation. Obviously, for commercial installations, you're going to have a lot more inverters. So that's going to depend for a commercial installation. For residential systems, you also want to make sure that a minimum 1-inch size conduit with a pull string should be installed between the main electrical room and the attic. The attic conduit should be above the insulation, so it's not hidden under a bunch of fiberglass. And the main electrical room conduit should also be in a location where you can find it easily in the future. So the conduit should also be run in a way so that it's easy to pull cable for the installation in the future. So avoid, lots of twists and turns in the conduit. And finally, just make sure that the conduit's capped, sealed, and installed to code. Next, you want to make sure that, and this is probably the most important point here, but you want to make sure that the main electrical panel bus rating is upgraded to the next largest size relative to the main breaker. This is done because by electrical code, your bus rating as well as your main breaker size will dictate kind of how much solar you could put in the future possibly. So for instance, if your main breaker on your panel is going to be rated 200 amps, you want to make sure that your installer or your consultant is upsizing that bus rating for that panel to 225 amps, which is the next biggest standard size. This is super important again, because if you need to go back and say you want to install more solar than your panel can handle, it's a very costly and a very time-consuming, well, not time-consuming, but it's very scope-intensive to try and retrofit that panel to replace the main bus. So definitely make sure, if you remember one thing electrically, make sure your bus is big enough. And finally, you also want to make sure that there's a spare breaker space in the panel at the opposite end to the main breaker. So for instance, in that picture, if you imagine kind of your main breaker, we don't have a picture of it there, but let's say it's at the top left there, you want to make sure that there's empty space at the bottom right of the panel for your future solar breaker. And again, that's just to meet code requirements. So if you're, before I go on to that point, I should say for commercial installations, the electrical designs may vary quite heavily from facility to facility. And it's recommended for those more complex commercial installations that you engage a solar consultant or installer to involve with electrical design. Just make sure that everything's designed properly and to code. If you are interested in further reading, a really good document to take a look at are the Nrcan Solar Ready Guidelines. It's from a federal agency, but it's a really good kind of guideline that documents the best practices for preparing a building to be solar ready.
Yeah, thanks, Nick. And I know our partner Canria was also involved in that Nrcan doc, so I'm sure it's informed our presentation today and has been a great resource. When you were describing the electrical considerations, I couldn't help thinking we're doing back to school shoe shopping for my kids right now. And of course, the first thing we're thinking is their feet are going to grow. So we're absolutely buying one size bigger because I don't want to have to buy shoes again in 3 months. So I think the more that we can get home builders and electricians thinking in terms of back to school shoe shopping, the better probably. All right, let's talk a little bit about some of the trends happening right now. We have reviewed the core elements of a solar ready build. However, you all know that folks are demanding even more these days. So lately, almost everyone who is installing solar is thinking hard or sitting on a wait list because they're hoping to purchase either all electric appliances, electric vehicles. Some are contemplating solar storage options, solar energy storage options. Of course, Tesla Powerwalls. I'm hearing a lot of folks talking about that these days. People are looking at essentially products that will complement a solar array. As things like air or ground source electric heating and cooling pumps, induction stoves, EVs, and storage systems come down in price, and as they are incentivized by government, and ultimately as natural gas and other prices go up, these seemingly fringe or niche items are becoming more and more mainstream. So I got a lot of calls about heating and cooling pumps as soon as people saw their utility bills over the past few months. So really interesting shifts there in the market. So for these types of additional considerations, it is strongly recommended that builders consider pre-wiring for 200 amp service, as well as meter-based disconnects to ensure no additional electrical panel or service upgrades will be needed. So I often talk to solar installers, they say, well, we don't really need 200 amp service. And it's not the solar that needs it, it's actually all the things that complement solar that might. So it's kind of like if you're at a buffet, the solar doesn't necessarily need the 200 amp, but all the side toppings that go with it might. So this is, of course, particularly important if you're integrating secondary or tertiary suites for homes. Again, just a reminder that if you're installing a 200 amp service, as we recommend, then you should put in the next higher electrical panel bus rating that is sold, as Nick mentioned, 225 amp in this case. Additionally, when going EV ready, or essentially making sure that a home has a charger, 240 volt, 40 amp branch circuit should be included at a minimum to any garage or private parking area. Adequate wall space will be needed in the garage or an outlying building that is not a dwelling unit, and conduits should be even larger than I previously mentioned to accommodate storage if desired. And that will definitely differ depending on the storage that's under consideration.
Yeah, thanks, Heather. Some super good points there. And I think it's definitely important to think, when you're putting in solar, it's something that's going to last 30 plus years on the roof. So definitely want you to think about some of those kind of adjacent technologies that might go in the future as well. So now we'll talk about building integrated solar, or BIPV. So these is kind of a bit of a newer technology out there. Essentially, when we talk about BIPV, we're talking about any materials that aren't a conventional solar module. So these might be things where the solar cells are integrated into roofing, siding, windows, railings, and awnings. Basically, any building material where the solar cells are directly integrated into the material itself. So here we have a few examples. Of note is the one in the middle, which is the Edmonton Convention Center, where it's actually glazing, so basically glass with solar cells in them. So it's a super cool technology, definitely a little newer, but solar BIPV rather is a bit more suited for commercial builds or multifamily homes, since they tend to be still a bit more of a newer technology, and they require a bit more kind of custom design and custom installation. So they are a bit more expensive than conventional solar PV modules. As well, they tend to have a bit lower energy production than conventional PV, just because their orientations or their azimuths may not be ideal versus conventional PV. Nevertheless, it's still a cool technology and something worth considering for your future builds.
Yeah, I can see that taking off in a big way in the future. So additionally, an alternative or related roof design consideration would be integrating solar for its greenhouse and shading attributes, as well as its generating potential. Of course, creating a solar-ready rooftop garden is not nearly as affordable as a basic solar-ready roof, but I know that a lot of people are passionate about a wide variety of green building designs. So I think it's important to mention that rooftop gardens and solar-ready rooftops, they need not be an either or choice. We can have both. I know I've seen a number of rooftop patios and gardens going in near where I live, And I hope folks will consider some of these unique designs that we're seeing in this photo here from Jasper Avenue in Edmonton.
Thanks, Heather. So while all these solar ready design considerations are extremely important and can help set folks up for an easy install after purchase, there are a lot of benefits for builders working with professional solar installers directly, straight from the design stage. So not only can the solar installer help you think through many of these solar ready build considerations prior to investing time and money in a new build, but having a partnership or a good working relationship with the solar installer from the outset can help your clients with the benefit of having a one-stop shop as well. It's a lot easier for new homeowners to finance their solar installations as a standard addition to their new home financing mechanism, as opposed to having to put into place a second financing mechanism at a later date. So here in our picture, we've got a great example of a strong partnership that's developed between Jamin Built and Skyfire Energy. They're working together to provide green turnkey product for Albertans where the solar is already on the roof, so it's ready for them once they move in.
And of course, there are some builders, you know, like our sponsor Habitat Today, as well as Avalon Master Builders, who are integrating, you know, they're integrating the installation component internally. So they're making sure they have internal capacity to have that component rather than going through a partnership approach. So there are a variety of ways you can do this. You know, you can have the in-house capacity, you can have wonderful mutual referral relationships, or you can have formal partnerships. There's really a lot of ways to make sure solar ready and solar integrated design happen. So yes, Avalon Master Builders, they have a good example of folks who are integrating that solar right into their brand and their company.
Yeah, so another option is also for municipalities to develop their own solar ready or solar integrated neighborhoods, as opposed to relying completely on builders to start the trend. So here in our photo, we've got a picture of Drake Landing community in Okotoks, where this sort of initiative has taken shape. So when we're kind of shifting our mindsets, thinking about building specific design principles as opposed to community design principles, there are a few different factors that we want to take into consideration, especially. So first off is street orientation. We want to make sure that we're laying out the streets in kind of a grid fashion, as opposed to curved lines and having cul-de-sacs, just to make sure that we have that good south-facing roof solar access. Secondly, we want to be conscious of shading. So, you know, thinking about, hey, where do we want to put our trees where they won't shade our PV systems that much? And lastly, we also want to think about electrical infrastructure as well. So working with the wire service providers to make sure that your distribution and transmission infrastructure is set up for solar, but also kind of electric vehicles and other technologies that we might have in the future.
Yeah, so municipalities can also promote green technologies through solar-friendly policies. Some policies to consider are municipal allowances for design variants to facilitate energy efficient retrofits or power generation upgrades. For example, you could, the maximum height or setback requirements could be adjusted slightly. Consideration should also be given to bylaws that support higher standards than the provincial or federal energy codes. I know we're in the process of adopting new federal energy codes provincially. So those codes, of course, will likely not get us to net zero buildings, but there are in the new codes, there's opportunity to set higher tiers at the municipal level and hopefully be able to accomplish some goals that way. Not for every municipality yet in Alberta, but those with the city charter might have some opportunities there to set the bar higher. So of course, other municipalities could look at bylaws that require things like solar above ground parking lots. So, you know, some municipalities have a lot of above ground parking lots and they're just kind of sitting there, not doing a lot. So one thing they could do is integrate solar into all of those. It could also mean requiring builders integrate some of these solar ready design principles in order to receive permits to build. reduce any zoning, design guidelines, and restrictive covenants that could prevent the adoption of solar PV. That's an important step municipalities can take. Solar installations can add considerable value to homes. However, it is recommended that solar-friendly municipalities not include that added value in their property tax assessments. In order to accelerate the adoption of solar, it is also best to avoid green on green controversy. So that's why I mentioned that we don't have to have a debate between rooftop solar or rooftop gardens. We could theoretically have both. But we also want to encourage you to watch for the launch of our solar siting recommendations in August. Solar Alberta has put together some solar siting recommendations to reduce that green on green controversy and hopefully make sure we can develop solar and strengthen all of our ecosystems together. So for more information about solar friendly municipal planning in general, please be aware that our partner MCCAC has a guide in place. And if you just Google solar friendly municipalities and MCCAC, it'll pop right up. So definitely check that out if you're looking at some of the broader systemic issues and less at the individual home level. All right, so that is all we had time for today in terms of presentation, but we're really looking forward to diving into the Q&A session now with you. So I'm going to pass the mic back to Mackenzie, who's going to moderate our Q&A session here.
Hi, everyone. Thank you, Heather and Nick, for that informative presentation. And thank you again, Rick from Habitat Studio, for sponsoring today. Let's take a look at that Q&A box. Just a reminder, if you have questions, to pop them in the Q&A box, which can be found in your Zoom toolbar at the bottom of your screen. So our first question is, are solar panels liable to danger from such things as hail, storms, or vandalism, like someone throwing rocks at the panel?
I feel like I should start and Nick, you should finish, because I get this question all the time, and I'm not going to speak too much to the technical aspect. I'll leave that to you, but I know that solar panels are actually very strong. They are used in parts of Alberta actually to protect things like livestock and car dealerships. So solar panels, generally speaking, can withstand very normal hail. Of course, if a hail was the size of a fist, I don't think anything's going to stand up to that. But Nick, do you want to expand on some of those topics?
Yeah, for sure. I guess back a few years ago, I can't remember if it was 2018 or 2019, when I was working for NMAX, there was that big hailstorm down in Calgary, where it destroyed like the siding of a lot of people's homes, unfortunately. But I got some pictures from our installers out in the field where, you know, some of these houses had solar panels installed on the roof, and surprisingly, all those solar panels were okay, even despite the big hail we had that year. So I think that's pretty testament to the resistance of modules to hail. As well, most modules from reputable manufacturers, they are tested to a certain standard where basically they'll throw a minimum size 1-inch diameter hail at a certain speed at the modules and see if they get damaged. And if they meet that certification, which most of these modules on the market do, then yeah, they're okay, and they'll survive, you know, most hailstorms. Again, it depends on the size of the hail. Now, I guess when it comes to vandalism, it depends as well. I mean, it depends on the rock, you know, how hard someone's throwing at it. It's like how big the rock is. But, you know, for the most part, they are pretty robust. It's not like you're going to drop a penny on it and it'll explode, but they're pretty robust in general.
Yeah, not to mention if they're on your roof, they're a little hard to vandalize compared to, you know, a window or something. I think that would be a really important question as well for the solar integrated PV, because then it's a little bit more accessible to vandals, theoretically, if it's on the siding or whatnot. So that's a good food for thought. I've heard the main issue in Alberta is really just, you know, pigeons and bird droppings and whatnot, and that's the main consideration. But one other thing I was fascinated to learn is that even if you have some damage to a part of a solar panel, apparently the other modules can still often be working. Is that the case, Nick?
Yeah, it depends. It depends. So there's bypass diodes on the modules, but yeah, basically your module, if you look at it, it's basically, you know, 72 cells or 60 cells. and each of those is relatively independent. But yeah, the answer is it depends. But yeah, there's some kind of bypass built into those.
This is where it's kind of important to understand the difference between a solar panel and a solar module, and the fact that the panel is made up of many modules. And I think a lot of Albertans aren't actually aware of that, and they think those terms are interchangeable. But fortunately, I was educated about that in my first day on the job. So, all right, Mackenzie, what else have you got for us?
Thank you. So the next question is, what programs do you use to design your solar systems? I think this is specifically for Nick.
Yeah, I can take that one. So there's several programs. I guess the biggest one for kind of the scale of solar we're talking about is one called Helioscope. It's one that's kind of one of the more commonly used ones here in Alberta. So that's Helioscope. That's kind of our main tool that we use for preliminary layout, kind of preliminary production. So, if we lay out the modules at this angle, at this location, how much will it produce? There's also AutoCAD, which we'll use for kind of more CAD and layout work, but I'd say Helioscope is kind of the big one at the scale that we're talking about here.
Excellent, thank you. Now, the famous question, what about winter snow covering on your solar panels? Should you sweep it off or just let it melt?
We love this one. Nick and I have a whole slide about this in our Solar 101 presentation. So if you haven't seen that one, it is up on our website and you can hear more about snow, but I can try and summarize it here briefly. Solar Alberta was very fortunate to participate in a Nate and Hal Mayhew engineering study about the impacts of snow on panels here in Edmonton, and discovered that actually there's only a 3% impact over the course of the year. The reason being, of course, the time of year when we have the most snow is also the same time of year when we have the least light. And so, of course, those two end up resulting in not a huge impact on your array. Nick, do you just want to talk about how the installers will size those arrays to adjust for snow cover and the lack of light in the winter?
Yeah, so again, kind of through that software that I mentioned earlier, Helioscope, there is typically, if your solar installer knows what they're doing, then they'll kind of adjust for the snow losses in the winter. So if you think about it, a very low pitch or flat pitch sort of module will kind of accumulate snow a lot more, and it'll be harder for it to slide off. Versus if you got a roof that's looking like this, it's gonna be a lot easier for the snow to slide off. So that is typically something that's modeled as well. If you think about it, in the winter, that's when we get the least lights. So that's the least production under solar modules. So yeah, like having the snow on there during the worst performing months of the year isn't a huge deal. So typically we'd say that it's not worth the time or the cost or the safety risks to clear the snow from your modules in the winter.
Yeah, like unless you're really expert, clearing snow from your modules could definitely cost you more than the 3% you're losing on the snow. So it's definitely not worth the risk, but I appreciate you elaborating on that. The sizing piece is interesting. I just realized the other day someone was explaining to me that, my home was sized to a 7 kilowatt system, even though we're only using it as a 6 kilowatt system, because essentially we're oversized to adjust for the fact of the snow as well as the lack of light in the depths of winter, according to our roof angle. So so you've covered all those points so well, Nick. Thanks.
Excellent, thank you. The next question is, are there solar systems that can be used for greenhouses that need the light to pass through them?
Solar systems that can be used for greenhouse. I think we showed a picture of one like that, didn't we?
I think you
On
might
the top of Jasper Ave. We should look for the reference. I think that was a really cool one.
Yeah, I guess while we're looking for that, short answer is yes, there are. That's something that's covered more under the Building Integrated Photovoltaics, or BIPV. So one manufacturer I would recommend you to Google is, they're called Onyx, O-N-Y-X, Onyx Solar. So they produce modules where it's either kind of like what we see on the Edmonton Convention Center, where it's like opaque cells and lots of space between cells so that it lets lots of light through. But they also kind of have this technology called amorphous silicon, where it looks like a tinted glass. So it'll let some light through, but it'll also generate some electricity. So it does exist. I personally haven't seen it on a greenhouse yet, but theoretically, you could do it.
You could totally do it. And I mean, from an agrivoltaics perspective, it's happening all the time, right? So on the large utility scale systems, there are more and more farms coming out with solar and livestock integrated, or solar and crops integrated. And there are studies showing that by mixing and matching, you can actually keep the water in the soil longer. You can enhance the vegetation growth underneath. Some people are actually having to bring sheep onto their solar farms just to manage all the weeds, because there's so much growth caused by the solar just being there and supporting the greenhouse effect, I guess, for your farm or your garden needs.
Excellent, thank you. The next question is, what changes do you think local power utility providers need to make to their infrastructure to support the greener future proposed in this webinar?
Yeah, so we've actually been working hard to advocate through the Alberta Utility Commission. They've been doing consultations on that very question. And our stance is that we should have a province-wide standard of 200 amps, and that type of service, especially for new, greenfield developments, is really going to be necessary into the future. I know there are many kinks to overcome from a distribution and transmission perspective. So it's not just as easy as regulating and make it so, but that's definitely the position we're taking. Not because the solar necessarily needs it, but because all the solar related technologies are going to need that increased service. And so we want to make sure that we're advocating for not just solar, but also solar related technologies. Anything to add on that, Nick?
No, I think you covered most of it there. Yeah.
Awesome. It's nice to see, the ISO had their net zero consultations last year, which we participated in, and we have a speaker coming to the solar show about that. And now the AUC is having conversations about standards, and the GOA is looking at regulations. So there's a lot of discussion about that right now. I think people are realizing we really have to step it up to have and to enable more distributed energy production.
Excellent, thank you. And I just want to remind everyone that the recording of this seminar will be available on our YouTube channel by tomorrow, hopefully. So if you're looking for a recording or the slides for the presentation, you'll be able to find that on our YouTube channel after the webinar. The next question is, do solar panels have built-in lightning protection? If no, how often is lightning protection added externally? Is it only implemented for tall buildings?
Yeah, I can take that one. So I actually just have been having to deal with lightning protection for the first time. To be honest, a lot of the industry right now, I don't think is taking a look at lightning protection. And to be honest, I'm not enough of a lightning protection system expert to know whether or not that's something to be of concern from. I guess to answer your questions, do they have built-in lightning protection? The modules don't. Typically, you'll have surge protection devices installed in your inverters to make sure kind of your rest of your building electrical system is protected. But the modules themselves don't typically have lightning protection added on. If we do add it on, what it looks like are tiny little lightning rods that we'll put kind of across the roof. Obviously, the downside to this is it'll cause some shading to your panels. But to be honest, I don't know the impacts of whether or not that's something that should be done for all systems. I do know there are standards out there, such as CSA B72, that talk about it. But kind of standard in the industry right now is just to properly ground and bond your solar system, but not necessarily install separate lightning protection systems. And that's also the case for utility scale. So the really big systems, they typically won't have a separate lightning protection system, for better or for worse.
Mm-hmm. Thanks for that, Nick. I wasn't aware of that. My daughter was actually asking that the other day because there was a big thunder and lightning storm, and she said, what is the impact of that on the solar? I mean, obviously it was nothing, but if it's properly grounded, there's not a safety concern there, hey?
Excellent, thank you. Now I have two questions. The first is, what's the payback average in Alberta and Canada for a solar PV system install? And then the follow-up question, is there any studies about the distributed generation capacity on the grid? So the amount of solar PV systems that can be installed while keeping the grid reliable.
I'll touch on the first one, and then of course we can pick up on the second one. Question about pricing. So that changes actually quite dramatically, even from month to month. And so I know when we first started giving our Solar 101 presentation like 2 years ago, all about the pricing, you know, we were often saying average price for a, you know, 6 kilowatt system, if that's what your home requires, would be maybe around 15 grand. Just kind of ballparking it. But that's changed. You know, the price of solar PV did go up in the last year. And so we are seeing systems that are a little more expensive. However, the incentives were also increased. And so now people can get like $5,000 off their install. So when you combine the fact that, you know, the demand is up, and so systems are actually a little more expensive with the new incentives that are in place, the payback time is probably about similar, around, I'm guessing around 10 to 15 years. But again, it depends. You can increase and speed up the payback period by reducing your energy consumption after you get your install done. So a lot of it also depends on the behavior of the consumer, whether they're participating in the solar club here in Alberta, which will increase or speed up your payback time. Lots of factors play into it. Ultimately, anytime you get a solar quote, they should be incorporating more of a current, recent payback estimate for you. So good solar installers will do that as part of the process because it is changing month to month. Thoughts to add to that one, Nick?
Yeah, I think that's about it. Essentially, back when I was working more for an installer, we think of it as two things on either side of the scale. Like the first one is how much are you paying for your system? So that includes things like rebates, you know, our modules getting more expensive. And the second thing is how much is your system producing and how much you get paid for that. So like the solar club will pay into that. If you have a really good south-facing roof with the optimal pitch, you'll pay off a little faster. So lots of things, but I think the 10 to 15 year mark, you know, pretty much hits it. And one thing to keep in mind too is that sounds pretty long, which, you know, it is, but also it's a bit of a revenue generator for 30 to 40 years. A lot of the utility scale models or systems that the developers will model, they'll model them financially for between 30 to 40 years, just because they should produce energy for that whole time. So yeah.
Yeah, it's not often that a home improvement actually pays for itself. So I wish kitchen redesigns paid for themselves somehow.
Excellent. And then that follow-up question was about if there's any information about the distributed generation penetration capacity on the grid, specifically regarding solar PV systems that can be installed and keeping the grid reliable.
So when you have distributed energy, it actually enhances grid reliability, right? So I think even Premier Kenny was speaking to that. He was putting through Bill 22, and he was talking about the importance of distributed energy generation for the purpose of grid reliability. The challenge when it comes to grid reliability is not so much the solar energy production, it's the fact that we are going to be putting so much more pressure on the electricity system in the coming years with the electrification of vehicles. And so it's important that we think about reliability and actually accelerate and enhance the distributed energy production to match the fact that we're going to have so much more pressure from the electrification of our entire system. So that's a bit of my thought on that topic. How about you, Nick? Anything to add there?
Yeah, so I guess a few facets to that question. If you're interested in the current penetration in the market of DG, I think the AESO, so AESO, system operator, posts some figures on that. I guess with regards to keeping the grid reliable on the whole. So every time you apply for a system in Alberta, it depends on the system size who will do the studies, but engineering studies are done to ensure that the power system stays stable. and the wire service providers here, so the people who own the distribution and transmission systems, they have it in their interest to make sure that it stays reliable. Whenever you want to do a solar system in Alberta, those engineering studies are done either by the wire service provider or the large developer. But there are measures in place and processes in place to make sure that system's reliable, and they will, make sure that the system stays reliable. So yeah, basically whenever someone applies to build solar, they will do those studies to make sure that system operation isn't affected.
Yeah, and I actually did hear about, especially in rural Alberta, sometimes there are issues where they can't accommodate new systems. And so I did hear that, a ComGen system, community generation system of 2 to 3 megawatts was rejected in Fortis territory because they couldn't handle it in that particular part of the grid. So there are safeguards there to protect Albertans and make sure that as we're distributing our energy that we can actually accommodate it. And all those wire providers are having to build out and up. And hopefully we can get some more transmission support as well. So there's a lot of factors there. So I appreciate you mentioning that, Nick. There are safeguards in place. And if anyone is producing a large amount of solar, they definitely have to jump through a lot of hoops. At the micro level, and especially in urban centers, it's much less of an issue, which is why we have such expedited permitting, and we don't have to go through the 2 to 3 year rigmarole that the big solar farms have to go through.
Excellent, thank you. And this question is about maintenance for your modules. What is the cleaning frequency for them for dust cover, etc., recommended in Alberta? So kind of related to that snow question as well.
Yeah, so cleaning frequency, if it's on your roof, is never. You basically just let the rain do that, and you're not supposed to go up there. If you go up there to clean it or brush snow off, there's a very good chance you're actually going to wreck your installation and cost yourself a lot of money. So you just need to allow the rain to do its business and don't worry about cleaning it. You can put bird guards, and there are products in place to reduce the chance of birds getting up to their business there. But Nick, do you want to expand on that a little from a practical perspective?
Yeah, that's exactly it. Our typical recommendation is don't worry about it. Because the rain and the snow will clean some of the dust off from the modules. It was actually interesting. I think this is more a problem in humid climates such as Hawaii. When I was there, you'd see there'd be this kind of like thick red dust on the modules, and in those climates, and yes, it may make sense to clean off that dust yourself. But yeah, here in Alberta, it's pretty dry. Like the dust doesn't really stick. So between kind of the rain and the snow, it'll clear your modules off enough. And then as well, in terms of the production losses from the snow and the dust that accumulate, it's really not worth your time or your efforts. And again, like the safety risks to try and clean your modules yourself.
Mm-hmm. I mean, there are, you can get maintenance done if you have significant issues, right? Or there's some kind of production, something stalling production. It is possible, just don't do it yourself unless you're trained in it, and you can do it without wrecking your installation. I did have a friend she had one of those big trees next to her solar installation that was shedding this year because there was like the drought last year, and then I guess all of these evergreens started shedding this year. I don't have evergreens around my home, so I wasn't aware of this, but she was concerned. So all this yellow dust all over her array, and by the next day the rain had washed it off. So again, it's a 1 or 2 day concern, not worth the risk of getting up there and trying to blow it all off yourself.
Excellent, thank you. The next question is, who installs devices to mitigate the danger from snow sliding off the roof?
So, like if it comes, we had this, I'll tell you what device I'm gonna get, because it's an awning. So we have this challenge where our snow slides off right at our front door, which it would slide off anyways, but because of the solar, it kind of comes off in a chunk. You get that big thwomp, the snow is coming off the array. And so we are actually just going to put an awning over our door so that it then protects anyone walking out the door and would slide off it. So that's pretty cost-effective way to deal with that. Have you heard of any other techniques? I know at my parents' home, it's a non-issue because when the snow comes off, it just falls down right in front of the window in front of their home. So I think it depends a lot on your home and where that snow's coming off. But I'm guessing awnings are probably the cheapest solution for that. And really, it's an issue like 1 or 2 days of the year. You can also just like be aware that it's probably going to fall off and maybe not go to that particular spot in your yard. What are your thoughts, Nick?
Yeah, I think an awning works pretty well for residential. For commercial installs, where sometimes we'll get these giant metal roofs, where it could be more of a consideration. I guess first off, like your bare metal roof is going to snow shed the same amount as your solar modules, maybe a little less chunky, but they're kind of equally as slippery when they're wet. So usually there's kind of snow stopping devices. I don't know the proper terminology for them, but basically they look like little rails that'll break up the chunks of ice and snow that come down. And for who installs that, that'll typically be a roofer, either a roofer, or if you talk with your solar installer, they can probably also get you in touch with the right people.
Mm-hmm. Yeah, we have, at times Solar Alberta has had some roofers who, you know, tailor their supports to the solar sector. So they're definitely out there. I appreciate you mentioning that, Nick. And it is always important to think about the commercial aspects, because I always automatically go residential, but it's a very, very good point, especially if you have liability involved in not accidentally covering your patrons in snow once or twice a year. Also, more of an issue with climate change, because of course the variability means we get, you know, those snow melts more regularly. You know, in the past, snow would come and it would stay for longer. And now it's like it comes for half a day and then it's all shedding. So definitely a good question for the time that we are the time that we're in.
Excellent, thank you. The next question, are you able to tie the price of a system into the home's mortgage payments? And I think Heather will have the great answer for this one.
Mackenzie, we hang out too much. Yeah, she gets to hear all about my incredible financing. It was easier for me to integrate solar into my home purchase than it was to get my kitchen appliances. I actually had the solar up and ready to go before we even moved in, and those pesky appliances were a real headache. So yes, the short answer is yes. We do have a seminar through our webpage about solar financing. We did have a mortgage broker speak at that. You do need to find the right mortgage broker, because they do need to make sure they're actually talking to the financiers about this. Some banks are more prepared than others for it. Some will be kind of ready to jump in the time. The main challenge is the time frame, right? Because when you're working on your financing for a new home, you often have pressure to get it done. So some banks can work within that time to get you your solar financing. Others are too slow and they have to ask too many, you know, if they go up to hierarchy too many times and they can't get you your financing in time. This, of course, is less relevant now that the interest rates are so high on homes. Very few people will want to explore that option with high home interest rates. However, if we go back to where we were 2 years ago when I was purchasing a home and you've got low interest rates, then it's absolutely a great way to finance your solar. And I'm very thankful to have been able to do that. It's just basically, they just call it home purchase plus improvement. It's just one of your improvements among many, and it's no different than your appliances.
Excellent, thank you. And the last question in the Q&A, unless a few more pop up, is what are the most common preventative maintenance procedures through the different seasons in Alberta? So I think this is referring to the panels and the modules.
If you were to do preventative maintenance. Honestly, I mean, as a person who owns solar on my home, preventative maintenance means just not touching it, not going up there, actually ignoring it. So the more you can just ignore your solar, the more it's probably you're going to do well by your solar as a homeowner. I know that sounds really weird to all of you do-it-yourselfers. Every DIY person on the line is just like, what is she talking about? If you're operating commercially, you absolutely need to think more about maintenance. Nick, do you want to elaborate a little bit on that?
Yeah, I think for the modules, basically the common theme is don't touch it unless something's looking wrong. If so, then call the solar installer. Besides that, really, it's just making sure your inverters are happy. So that's just making sure that they're not getting overly warm, that the fans are still working, that the fans are clean and clear of debris, things like that. So that's the main thing, is make sure inverter is okay. Besides that, yeah, don't touch it.
Yeah, actually, this leads us to our next course committee meeting, Nick, because Nick is our course coordinator, course chair for our course committee, and we are going to have a good conversation about maintenance. If you're in charge of maintenance on a commercial solar array, whether we should start offering some programming about that. But from a residential perspective, just don't touch it. That's a quick course. We can charge for that, but we won't. So you get your free residential course today on just leave that solar installation alone, and we'll try and offer something more concrete for commercial folks down the road, because I realize there are a lot of people anxious to have just added solar to their inventory that they need to monitor and make sure it's effective. So even hopefully we can integrate some topics about how do you know something might be wrong, especially if you're looking at a commercial installation printout on your generation and whatnot. So thanks for that food for thought. We'll hope to bring you more course or workshop content on that particular piece down the road.
Excellent. So it looks like that's all the questions in the Q&A box. Megan will be popping the Zoom link for our after formal Q&A, the more informal Q&A meeting, where you'll get a chance to interact more with the panelists. You can turn on your camera if you wish. Rick and John from Habitat Studio will also be in that meeting. So if you have questions about their company or their organization and what they do, you can ask that there as well. So you can feel free to transition over to that Zoom meeting now. And I just want to take another chance to thank Rick and his team at Habitat Studio for sponsoring today's session, and also thanking Heather and Nick for taking time out of their day to answer all our questions and give us all this excellent information.